Welcome. It's April already, and so it must be time for the Solar Cycle 25 update for March of 2021. So what are we going to cover today? We're going to look at the sunspot regions that have emerged during the month of March, compare some of the statistics for the equivalent period between Solar Cycle 25 and Solar Cycle 24. We had 2 flares in March, greater than C1, and 25 coronal mass ejections. That's increasing. We'll take a look at the status of the solar wind. We had 6 geomagnetic storms during the month, greater than G1, and then we'll look at some solar dynamics and SOHO movies of what was going on the sun, and then try to draw some conclusions from all of this. The old saying goes that March comes in like a lion and goes out like a lamb, and that was very much the case for solar activity during the month. It started out fairly high and slowly degraded towards the end of the month until we actually got a couple of days without any sunspots on the sun at all. March of 2021 was the 3rd highest sunspot number during solar cycle 25 so far. As you can see from the very end of this plot, there was a slight uptick from both the January and February figures, although it still was behind what we got in November and December of 2020. The blue arrow here indicates solar minimum. Here is a plot showing the number of sunspot regions that emerged during each month. You can see we had a fairly high number during March of this year on the far right, but we're still also getting some small sunspot regions from solar cycle 25. There were 2 last month, but they both lasted just a couple of hours. We can take a look at how these were distributed between the hemispheres. In the northern hemisphere, we had 2 regions that were old cycle and 8 regions that were new cycle. In the southern hemisphere, we had 0 regions that were old cycle and 10 regions that were new cycle. You can reflect the change in the number of spots from the old cycle to the new cycle in a graph like this, showing that about 2 years ago, there were hardly any new cycle spots at all, but now there's over 90% of the spots that appear are in fact new cycle, solar cycle 25 regions. Some people like to put a lot of emphasis on the number of spotless days, and there have been a lot in recently because of course we've been at solar minimum. But however, we went 40 days without having a day without spots, and that was a long time ago since we had something like that. In fact, it was in October of 2017, so it's gone 3.5 years since that was the case. We can look how many flares we've had over the last month, and that was 2. That's disappointingly low, but nonetheless it's still some flares. And you can see that we still had 8 months that has had at least a C flare during it. We've even had a couple of M flares, which is quite impressive this early in the cycle. Now let's take a look at some SDO movies. This first one is a magnetogram movie. That's a movie showing the spatial distribution of the magnetic field on the surface of the sun. This is from the Solar Dynamics HMI instrument, and approximately 1 second equals a day in this video. The magnetic field convention here is that black areas are magnetic fields directed away from you. White is magnetic field areas that are directed towards you. Large, strong magnetic field areas are generally associated with sunspot regions. Now let's take a look at an actual sunspot movie over the same period of time. Again, it was from the Solar Dynamics Observatory HMI instrument, and it has a similar cadence to the previous movie. Spots you'll see move from east to west, that's from left to right. The visible light's image of the sunspots is a temperature of about 5700 degrees Kelvin. Now we're going to go up a little bit higher in the solar atmosphere into a higher temperature. This is helium-2 304 movies, again from the Solar Dynamics Observatory, but from the AIA instrument. The approximate temperature of the plasma you're seeing here is about 50,000 degrees Kelvin. And the thing to look here are the dynamic prominences on the limb and the filaments on the disk. These are the dark areas. The bright areas are sunspot regions, which show up as bright areas, like the one in the middle of this picture. Now we move higher into the corona to a higher temperature. This is an iron 9 line at 171 angstroms. Its temperature is about 630,000 degrees Kelvin, and it shows the dynamic coronal plasma. Note there's a lot of magnetic loop structures in this movie, and these actually connect the areas of dark and light magnetic field. Now we're going to go higher in temperature again, and thus higher in the corona. We're now at about 1.2 million degrees Kelvin, and this is looking at an iron 12 line at 193 angstroms. Note the dark areas near the poles, those are coronal holes. Now we're going to take a big leap in temperature. We're going to go up to about 6 million degrees Kelvin. And this shows when there's bright flashes in some of these regions, that's where there are small flares going on. So this is really a way of detecting the hottest plasma that is visible to this instrument. Now we're going to take a look at the two flares that occurred. This is the one that occurred on March the 3rd. It is a C1 flare. The second flare occurred on the 9th of March. It was a bit more spectacular because it was on the limb, but it was also classified as a C1 flare. Now we're going to take a very different look at the sun through a coronagraph. This is not on the Solar Dynamics Observatory, but on the SOHO instrument from the LASCO C2 and C3 coronagraphs. What happens here is that they block out the bright disk of the sun and look for the faint reflections of sunlight off of ejecta coming out of the sun, so-called coronal mass ejections. According to the coronal mass ejection database, we had 26 coronal mass ejections last month. And you can see since solar minimum, that number has been steadily increasing. We expected to get well over 100 by the time we get to solar maximum. So we're not a quarter of the way there yet. So what conclusions can we draw from all of this? Well, first of all, solar cycle 25 is well underway, and it seems to be moving along a lot faster than solar cycle 24, which probably means it's going to be a larger cycle. We just had the longest period without a spotless day for the last 3.5 years. The CME rate is increasing quite quickly, and over 90% of the new sunspot regions are from solar cycle 25. The few remaining solar cycle 24 regions are very small, very weak, and very short-lived. And eventually, I think, will just plain disappear. So until next time, stay safe and goodbye.